Good afternoon, my friends and brothers. My name is Edward Wasrom, the tutor in Edwards Academy. This afternoon, I will bring to you an interesting development in macroeconometrics. I'll bring to you how to estimate dynamic ordinary least square and how to have it interpreted in line with the ceteris paribus interpretation. The word dynamic OLX may be credited to the work of Stock and Wilson, and the reason behind the adoption or the introduction of dynamic OLX is because in the traditional OLX there is always an issue relating to asymptotic biases, which is also known as the violations of the major assumptions of the classical least squares. So due to the presence of asymptotic biases in the ordinary least square estimation, then it is also expected that the dynamic OLX will be introduced when there is complete cointegrations in a situation where your series became stationary after first differencing and you actually perform the Johansen cointegration test, and the Johansen cointegration test establishes the presence of complete cointegration among all hypotheses so stated. The best approach to actually use in such a scenario is dynamic OLX, because the dynamic OLX introduces a very strong techniques, a very strong mechanisms using the lags and the leads of different first difference series to actually correct all asymptotic biases in the equation so estimated. This afternoon I will introduce to you how to have it estimated. It's very simple, and also have to have it interpreted. Recall that in our previous videos we've been using the stock market series in our examples. This afternoon I'll be using the stock market variables and unemployment, and economic growth to see how we can actually learn together. So to have that actualized, we'll go to quick. From quick we move on to equation estimates. For the equation estimate, we specify our variable, starting with the dependent variable, the log value of ROGDP, followed by the log of number of transactions in the market, followed by the log of market capitalization (NCAP), followed by the log of value of transaction in the market (VTRAN), and we decide to add unemployment in the model, or we can just let's leave it this way. So without changing any other thing here, at the option box will remain ordinary least square. So within this method estimation settings, you go to this estimation setting box, you click and locate cointegration. So once you are at this equation estimation box, you come to non-stationary estimation settings here. You change this fully modify OLX to dynamic OLX. Then you lag and the leave it at fixed. You can also decide to change any of the information criterion, but I am leaving it at fixed. Let the system generate the appropriate information criterion for the study. Without changing any other thing, there is no constant in the estimation. The system will estimate with a constant. Deterministic regressors, leave it empty at the moment. Then without changing any other thing, if you click the OK button, you'll be exposed to a result that looks like this. This is how the dynamic OLS result comes in. Dependent variable is the log value of our GDP. The method is dynamic least square dollars. Dated this day. The sample after all adjustment will have 1987 to 2020, which is 34 years observation after adjustment. So we have our results appear like this. Long run variance estimate using the Bartlett kernel Norway West fixed bandwidth. This is the iteration procedure that was adopted by the system automatically. Then if you look at the results, our variable, the log value of number of transaction, market capitalization, and value of transactions. These are the coefficients. These are standard error. These are the t-statistics. If you divide this coefficient by the standard error, you get the t statistics. These are the probability values. So this is R square. The R square value is 83. The R square adjusted will have 74. That implies that 74% of the changes in economic growth is associated with the interplay of the stock market variables. We also have the mean dependent variance. We have the sum of square, residual, and host of other parameters that actually will be interpreted one after the other. If you start with the log value of the number of deals, it is positive, but this is not significant, which implies that number of deals is not a good predictor of economic growth in the country. Then you look at market capitalization, is positive and is significant, and that actually implies that when market capitalization increases, or a percentage increase in market capitalization will amount to 44% increase in economic growth, and that is okay. You look at the value of transactions in the markets is having a negative impact on economic growth, and that actually means that an increase or a percentage increase in value of transaction in the stock market will actually have a 40% reduction on economic growth. And this is against economic theories, so readers should be able to know the reason why the changes or variations in value of transactions in stock market will be having a negative impact on our GDP. The coefficient of the constant or the autonomous component is positive and significant, which actually gives the robustness to the entire model. So basically, the dynamic OLS regression or equation or output is better than the classical ordinary least square estimations, and you can only use the dynamic OLS if you have been exposed to a complete co-integration after your Johansen test. That is the only condition that you will be exposed to use this particular method of estimation. So you can copy it neatly to your paper, arrange them, level them, make them look nice to the readers if you are in this framework. This is how we estimate dynamic OLX. Thank you for staying tuned to my video. I promise in next videos I'll bring interesting development. Thank you and God bless you. Subscribe to my channel, advise your friends, your worlds, your students to subscribe to my channel, watch my video. Thank you and God bless you.